This conference will now be recorded.
Okay. Again, thanks everyone for joining. And today is the third session for the Git tutorial. Now, just to recap quickly, in the previous session, we understood what is the Git workflow, in which when you want to start your work, you have to basically do a Git clone so that you get a workspace on your machine in which you will also get a copy of your repository. So you have to modify the changes, and then you add to the staging area, and then you commit it to the repository, and post that you would be pushing the changes to the remote repository. The same way, whenever you want to update your repository, which is the local repository, then you do the git pull. And pretty much after that, we also saw how do we undo the changes. So that's where we have different types of undo. So typically, before you do the commit, if you want to undo the changes, then we use git reset. However, if you have already committed the changes and if you want to undo it, then you will be using git revert. But if you want to move from one commit ID to another commit ID, then we will be using git checkout. Now, with this, let's continue with the next topic what we have in the Git. The other important topic that we have in Git is called as branching. So let's kind of understand what is branching and why is it necessary and how to use it when we are working on a tool like Git. Now, ideally, I was always giving an example of bank, right, and your account. So I was trying to tell you that when you have a bank, you will have an account. And now let's say when you're trying to do some transaction on a particular bank account number, how is it being identified? So typically it is identified using a branch name, right? So let's say that you have an account in HDFC. Now, when you say HDFC and the account number is given, the account number is associated to a particular branch or an office, because this is how it will be easy for the bank to manage your transaction with respect to the account. Because if you're trying to open another account number, so typically that will be on another branch. So the same way, now when you go to a workspace or when you take a repository in Git, all your changes, which is nothing but your commits, are actually stored in the remote repository. But what happens inside the remote repository? It is not stored directly. However, there is one more layer inside your repository called as branch. So anything that you are storing and you're seeing the content will be with respect to a branch. Just like how your account number is associated to one branch, the same way now practically if you're saying that you are working on a repository and you are trying to see the files push or pull, so what exactly is happening is there is a layer inside it called as branch, and only in the branch you will be able to store the files and you will be able to view the files from a particular branch. So branch is that layer in which you actually store and view all your files. So now by saying it, anything that you try to store inside a repository will be inside a branch. So now when you created your remote repository, you always get a default branch called as main branch. And this is the branch in which so far whatever the commit we did and we were trying to store the changes and whatever we were viewing the changes is from this particular branch. So how it worked for us is, so now when we created a remote repository in GitLab, we got a default branch called as main branch. And when we do the clone, what you will get is the workspace, which will be the copy of this remote repository. And in this, you will also get the same main branch inside your local repository of the workspace. So whatever the changes that we did and we created the commit was all stored into this respective branch of your local repository. And not only that, remember this, whatever the pull and push operations that we were doing, it happens from the same branch of your local repository to the same branch of the remote repository. So this is how what we did, we created a repository which had a default branch. Then when we cloned it and created our local workspace, so we got the same copy of the main branch inside our local repository. And whatever the changes we did, we were actually committing it to the main branch. And when we were trying to pull or push changes from your local repository to remote repository, it was actually pushing and pulling between this branch called as the main branch, which is the default branch. Okay, so the first thing that you need to know is in Git, all your commits are stored and maintained in a particular branch. And not only that, if you say you are working in Git, definitely all your changes or commits will be stored in a branch and you will be working in a respective branch. But the question now will come is, okay, why do we need a branch? Why can't I just store directly into the repository? Now, this is where parallel development comes into the picture. What do you mean by parallel development? Now, the same product, let's say there is a product for which you have created a repository to store all the changes. However, for the same product, there might be different features that we have to develop or different functionalities we have to develop, or there might be different releases that we have to work on for which the development has to be done or the code has to be written at the same time, right? So that's where you will get into a lot of complexities if all the developers work on the same copy of the file. So this is where what happens now in Git, you can actually create multiple copies of your file and put it into different layer called as branch. So what it means now, in your repository, you can actually have multiple branches, and whatever the files and the commits that you store into a particular branch will be visible only in that branch. So this way what happens, one set of users can use a particular branch and they can see the files only in it, and they can try to commit and store only into that branch. So this way, any point of time, the parallel development will be easier when we follow this branching methodology. Okay, so even though when you create your remote repository, you get a default branch, we can actually create as many branches as we want. And in our workspace, that is in our local repository, you will get the copy of all the branches from the remote to local. And in this, you can choose which branch is that you are interested to work, and based on that you will be able to see only the files that is stored in that particular branch. And not only that, so now if a user wants to work on another branch like what I'm showing in the diagram as a release branch, then you can choose which branch that you want to work in your local workspace, and any commits that you do will be specifically stored into this branch. And the same way, when you try to do a push or pull, it will be from this particular branch to the same branch on the remote repository. So this is how you can have multiple branches on your workspace, and you can choose which one you want to work, and you can share the changes between those branches on your local and remote repository in the same way. So this is how, by having multiple branches, Git helps in parallel development. Okay, so in short, your actual changes are stored in a particular branch. So now a user have to choose which is the branch in which he has to work, and according to that he will be able to store all the commits only in that branch, and anything that you want to pull or push to the remote repository will always happen only on that particular branch. Okay, so this is how branching helps in parallel development. Now, by saying this, how do you create a branch? So this is where, if you want to create a new branch, we need to understand if this new branch, what you are creating, if it has to be used by everyone, then you need to create the branch on the remote repository. So you should not be using your Git client and create in the local repository, because only when you create a branch in the remote repository, it is going to be global and it will be available for everyone to use, because when they do the clone, they will be getting all the branches to their local repository also. Okay. However, the benefit of the Git client is a user can also create their own branch. Suppose, let's say you want to do some testing or a POC, and for that, you don't want to put the commit in any of the actual branches available in the remote repository. Then, as a user using the Git client, you can create a branch only in your local repository. But the other side of this will be, if you want to share the changes, then you cannot share the changes from this new branch, which is available only in your local repository, to the central repository or remote, because usually the pull or push will happen between the same branch on your local repo to the remote repo. So that way, the benefit of Git client is, if you want a branch only for your POC purpose or testing purpose, then quickly you can create a branch, store everything into this branch. However, if you want some changes in which everyone should be seeing, then you should first create the branch in the remote repo, and then you should be doing the clone, and you will get the same into your local repo, and then push and pull will happen between them. Okay. And next thing, so now when we say there are multiple branches in your local repo, okay? So as soon as you do the clone, whatever branches are available in the remote repo, you will get everything into your local repo. Now, this is where, so far, what happened was there was only one branch, and when we did the clone, we got only the main branch, which is the default branch, and whatever the content was the main branch is what you were already seeing in your working directory. That is, as soon as you go inside the workspace, you were able to see some files. What was those files? So those were the files which were corresponding to the commits that we had stored into the main branch. But now, when you have a repository in which multiple branches are there, how do you choose which branch you want to work? Now that is where, once again, the checkout command works. Because in the day one, if you recall, I told you what is checkout. So checkout is a process where you will be able to see the exact files based on a commit. But now every branch has different commits. So this is where, now exactly when we say checkout, the practical meaning of checkout in Git is take the content of a particular branch and show it in the working directory. So this is how, suppose if you do not tell anything, if you go to the workspace, by default it will show the content of the main branch. And not only that, anything that you do in your working directory will be going to only main branch. It is like selecting a branch by default. So if you want to now work on the release branch, then you should say git checkout and another branch like release branch. Then what happens? It will show the content of what is there on the release branch. The same way, if you want to work on another branch like test branch, then if you say git checkout test branch, then in the working directory, you will be actually seeing the content of the respective branch. So this is how the checkout command helps you to assign the contents of whatever the branch is there in the working directory. Okay, that means when you say checkout, you will be seeing the files corresponding to a particular branch that you have checked out. And the same way, anything that you do, the changes in your working directory will be going back to that particular branch in your local repository. And when you do a pull or push, it will be pull or pushing the changes from the same branch of your local repository to the same branch in the remote. So this is where you need to first understand that the branch that you're working in the local repository, is it needed for everyone or only for you? So that way, if it is only for you, you can create the branch directly from the local repo. But if you want to create a branch for everyone, then you should create it in the remote repository. Okay, so this is the concept of branching. So once again, just to recap, so branching is where Git stores everything. So all your commits are stored into a branch. However, for allowing parallel development, you can create how many ever branches that you want. And when you are trying to work, you need to check out to a particular branch in your workspace so that you will be able to see the content of only that branch, and whatever the commits you do will be going to that particular branch only. And when we do a pull and push, the pull and push will be happening from the same branch of your local repo to the same branch of remote repo by default. Okay, so with this, now let's try to see how the branching works in practical. Okay, so let me okay, so this is the workspace folder, and if you can recall, yesterday we had these two folders, right? So what we will do now, first, let's come back into the central repository and have a look about what is the default branch. So let me go back to GitLab. Okay, so let's check about my awesome project. Okay, so this was the project. Hmm. Anyway, let me just directly go to this. This was the repo. Let me just directly go to this. Okay. So here, if you come to the repository and if you come to branches, you should see that there is only one branch called main branch. And this is where so far in the previous sessions when we were trying to store files and we were trying to pull or push, it was all happening on this particular branch called main branch, which was the default. And all the commits that if you see was in this particular branch called main branch. Okay, so this was the only one branch. So this is where now if you want to create a branch, which is going to be used by everyone or a particular set of users, then you need to create the branch in your remote repo. So this is where you will be using the server tool like GitLab or GitHub, and you create and manage your remote repo. So we have used GitLab for our remote repository management. So now in this, let me create a new branch. Okay. So I'll just create a new branch here. Okay. And I'm going to give the name as release branch. So whenever you create a branch, it has to be associated on top of another branch. So it's not like you can create a branch from scratch. So in that way, now the branch that we already have is main branch. Okay. Because think of it like a tree. Now, when you have a plant or a tree, the plant has basically one main branch, which is called as trunk, right? And any small branches that it grows, right, it comes from the same main branch, or it will be from another smaller trunk. So this is the same way. Now in Git also, if you're creating a branch, it has to be based out of another branch. So since we have main as the only branch, so any new branch that I'm creating now will be based on that. Okay. So we will create a new branch called release branch. And what happens in Git, when you create a new branch out of another branch which is already available, then all the commit IDs and the files which are available in the source branch will also come to the new branch. So this is where, when we now created this release branch out of main branch, at this time, whatever was available in the main branch is also visible to your release branch. So that's where you can see now release branch also has all these files exactly similar to the main branch. Okay, so at this point of time, there is no difference between release branch and main branch, because whatever the content you have in main is also available in release. But however, as we move forward, if we modify something and if we try to commit and push, we will be able to store it separately into main branch as well as release branch. So that is how one user can work on main branch in his local repo, another user can work on release branch on his local repo. Okay, so they can do those kind of changes parallelly. So now let's try to work. So let's go back to the command prompt. Okay, I hope it's visible. Okay, so now let's create a new workspace. And this time I will say git clone, and this is the same project. And now let's say workspace 03. Okay, and watch this now. If I go inside the workspace 3, what happens? You can see that there is something pointed called main. This is because by default, the main is the branch. So because of that, by default, you don't have to do any checkout. You will be able to see the content of the main branch. So what you're actually seeing is the main branch. And not only that, you can confirm if you say git log, you should also be seeing all the commit IDs only with respect to main branch. Okay, so this is where, how do you switch from one branch to another branch? So typically now we have two branches here, right? One is main branch, another one is release branch. So for the git, there are commands that we can use for this. Now this is where, let's come back to this. Okay, so yesterday we were talking about just saying git checkout under commit ID. But in fact, now how it works is you need to say git checkout and you need to do a branch. So this way you will be able to switch from one branch to another branch. And how do you confirm that? So that's when, if you, okay, let me just go up. Yep. So now if you use the command called git branch, okay, it will try to list you all the branches that is available for you in your local repo. So see this. So I'll go back here, and now if I say git branch, you can see there is only a branch called main branch, and the star here indicates that current branch that you are working on is main branch. Okay. Now the question will come, hey, we just now created a release branch. Where is it? And why is it not visible? Now this is the nature of Git, because what happens in Git is you are cloning the entire remote repository to your workspace. And this way, all the metadata is actually downloaded to your workspace. However, if you try to see all the content, then the size of this workspace will be huge. So that's where what Git does is only when you check out to a branch, the content of that particular branch will be visible to you in the remote repository. If not, everything will be stored only as a reference. So that's where right now when you say git branch, it is showing only the active branches in your local repository in which files are visible. However, if you want to see all the branches available for you or the references that is stored in the local repo, you can say branch hyphen a. And now you can see it shows that along with the origin, you also have a branch called as release branch. So understand this now. In the local repository of this workspace, the reference of the release branch is available. However, the content of that branch is not visible to you. And only when you check out to that branch, it will be visible to you. Okay. So now watch. If I do git checkout and the branch name. So the branch name is release branch. So what happens now? The content of the release branch will be visible, or when you say checkout, you are actually switching the context from main branch to your release branch. See this now? And this is where when you do the checkout, the references has been pulled from your local repository and it shows you the content of that in the working directory. And that's what it clearly says, that we have switched the context to the release branch. And at this point, if you say git branch command, and it should clearly now tell you there are two branches available. One is main and another one is release. Now out of that, the star indicates where are you working. The same thing you can also see here. Okay, so this is the first thing. How do you switch between branch? And also remember, when you do the clone, all the references will be available in your local repo, but only when you check out to the branch, it will make it visible for you in the working directory. Okay, but if you want to see all the branches available from the remote repo, then you need to say git branch hyphen a. So a indicates all the local branches and the reference of the remote branch. Okay, now let me again show you. So this is your release branch, and you should also see all the files and the commit IDs available on this branch, because we created the release branch from main branch. But what we will do now, let us do some change, and now when I store it, it will be storing only on the release branch of your local repo. So let's create a new file. Okay, and I'll call it as release file. Okay, and I'll add it and we do a commit. So now what happens? The commit that we have done is specifically to the release branch. That means it would have created a new commit ID only on the release branch, and this file called release file is only available on the release branch. Now let me show you this. So you can see it created a new commit ID called 7EE. Okay. Now, this is where our head reference is, and it is pointing to release, right? Which is the release branch. And now, at this point of time, let me check out to the main branch and I'll show you. Okay. So this is the file. So now see, if I say git checkout, and if I go back to main branch, so I've switched the context to main branch. Okay. To confirm that, you can say git branch and it will show you that the star is on the main branch now. So that means you have not on the release branch, you have switched the context to main branch. And now if you see a ls, you shouldn't be seeing the release file. That's because Git will check out the branch and it will show you the commit IDs only on that branch and the files only on that. Okay. So, okay. So now, same way, if I do some change on the main branch, it will be available only on this branch, not on the other branches. So quickly, what we will do, I'll create a file called main file and we will add and commit. Now, this commit and the file will be available only on the main branch. Okay, so you can also see, so after the 612 it has created a new commit ID called 0t, whereas this 0d97 will not be available on the release branch. Same way, that commit ID, that whatever we did in the release branch, is also not visible here. Okay, so now watch this. If I switch or check out to a release branch, this file and the commit ID will not be available. Okay, so let me do a git checkout to release branch. Okay, and you can see now we have switched the context to release branch. So now here you don't see the main file. Okay, at the same time you will also be not seeing that commit ID, whatever we have done in the main branch. So this is how you can switch to a particular branch of a choice, and when you do a commit, you will be doing the commit only to that branch and you will be able to see the content of only that branch. Okay, and now watch this. If I do a git push, where am I? On the release branch. So this is where the commit ID of your release branch in the local repository will be pushed to the same branch, that is the release branch of your remote repository. Okay, see this? And this is where, if you look at the last line, it will be very clear that your commit is not getting stored in your remote repo directly. Inside the remote repo, it is storing it into the release branch. Okay, and this is where now what we have done, we have updated only the release branch of the central repository. Okay, or the remote. So if you come back here to the remote repo, okay, and if you just refresh, so you should see that on your release branch, you have this file called release file. Okay, and corresponding to that, you have a latest commit ID. Now, this is the 7EE, which is the latest commit. Now, if I go to the main branch of my remote repo, you shouldn't be seeing the main file that we have created. Okay, so that is because we have not pushed the main branch content. So that is where in Git your push or pull happens exactly between one branch of your local repo to the same branch of your main or your remote repo. Okay, so you need to understand this concept. Now, how does it know all those things? Now that's where, if you go back to the first day, when we were setting up the Git client, we were setting up a configuration called push.default is simple, right? So the meaning of that push.default simple is, when you are working in your Git client, any push and pull that you are doing, go to the remote repository, or what we call it as the origin. Origin means this is the parent from which you did the clone, right? So by default, whenever you do the push or pull, it should always go to the parent or the origin remote repository. And in that, the name of the branch should be the same, as well as the source and destination should be the same. So that's how push.default was helping us so far. So that's where, so far, whatever we did, when we did a push or pull, we didn't tell where is your remote repo. At the same time, we didn't tell what is your destination branch, because current branch is your source branch, whereas the destination branch was the same. So that's when we were using the push.default as a simple method. And now if I want to push the content of the main branch, then once again I should git checkout to main. Okay, so now you should be seeing the main file here. And from here, if I say git push, it should exactly go to the main branch of the remote repository. So you should see in the end. Okay, so it says it's pushed. And now come back to the remote repo, and if you refresh, you should see that this file is available. Okay, so this is how in Git you create branch, and you will be able to switch the contents and store the content specific to the branch. Okay, now what we saw is, if you want to create a branch on the remote repo where everyone can use, then we create the branch on the remote repo, and then you clone and start doing the work. However, what if you have a requirement where you want to create a branch only on your local workspace, so that you don't want to share it with anyone? Then you will be using the same Git branch, and you just give the new branch name. Okay, so now what will it do? It will create a new branch only on the local workspace, or only on your local repository. So watch this now. So I'll go back here, and now again you can choose from where you want to create this new branch. Now I am in the main branch, so if I say git branch, let's say a branch called test, then test branch will be created from main branch. Suppose if you want to create this branch out of release branch, then you should check out to release branch and run this command from there. Okay, so now see, if I say git branch, you also have a new branch called test branch. Now, why is it directly showing here without using a -a? This is because this branch is directly created on your local repo, so there is no need for the reference. Only when you do a clone, the references will be downloaded, then you have to choose whether to see it or not. Okay, now if I go to this branch called checkout test branch, you can see it's switched to the test branch, and here you will have everything that the main branch had at that particular time. However, if I do some change now in this branch, it is going to be available only here. Now just to see this, what we will do, we will create another file. Okay, and I'll just call it as new file. Okay, so the commit and this new file is available only in test branch. And if I go back to any other branch, so let's say, let me switch to main branch. and you should not be seeing that new file here. Okay, so this is available only on the test branch. So this is where if you have a requirement where you want to do some changes only to be available for you, then you can create a new branch and work on your local repo. So that's where create branches using Git client only if the branch is needed for you. If the branch is going to be used by multiple people, then you should always use the server, which is your remote repository like GitLab, and create the branches there. Now, however, watch this. If I do a git push from the test branch of your workspace, it will give me error because it clearly says you are trying to push from the test branch of your repository, that is the local repository, to the test branch of the remote repository. And there is no branch called as test branch in the remote. So that is where it will not work. So as a best practice, like I said, if there is a branch which is needed for the product releases or for people to work in the project, then you should always create it in the remote. But if there is anything that you want for your own testing purpose, then you can create it within this. Okay, so basically that's the difference. All right, now we understood what is branching and how do you create branch and how do we basically switch between the branches and how do we store and view the content. Okay, so branching is mainly for parallel development. Okay, and the benefit of Git is you can create as many branches that you want and you can switch, and you can create it globally for everyone in the remote repo, or you can create it locally only for your work. Okay, now let's understand the next concept. Now this is where I told you, when you try to create a branch, what happens? You always have to create a branch from another branch, right? Because for creating a new branch, you need a source branch. So like what we just now saw, so let's assume you have your main branch, and from there we created a release branch. However, once you create a new branch, all the commits that you do in the release branch will be stored only on the release branch. Now, the same way, when you try to do some commits on the main branch, then the commits will be available respectively only on the main branch. Now, just to differentiate the branch, I've just used these colors. Now, let's say over a period of time, you have been storing all the commits and all the files and its changes are only visible to a branch. But at some point of time, like for a complete release, you want to combine the files from one branch into the other branch. Okay, so combining the content of one branch into another branch is what we call it as a merge or a branch merging in Git. So in Git, merging means take the content of one branch and copy that to another branch. Okay, so that is what we call it as merging. So now, for example, I've been working on a new branch, and if I want the content of this branch to be merged to my main branch, then your release branch will be the source and your main branch will be the destination. And when you do the merge, what happens? So merge takes all the commit IDs that is available on the source branch and it will merge to the destination branch. So in this example, so you can see, suppose the main branch has this commit ID called ABCD. Your release branch has this new commit ID called EF. So when you merge from release branch as the source and main branch as the destination, then what happens? Merging will take all the commit IDs and it will put it to the destination branch. So this is where now when you go to main branch after your merge, you should be seeing additional 2 new commit IDs, so that you will be having all the existing commits plus the new commits which came or which got copied from the source branch, which is the release branch. Okay, so this is what we call it as merging. So when do you do, or when you need to do merge? Whenever you want to combine the code from one branch to another branch. However, when you do a merge, what happens? All the commit IDs from the source branch will be copied to the destination branch. Okay, so this is one method of combining the contents of the branch. However, there is one more concept called as cherry pick. Now, why do we need cherry pick, or what is cherry pick? Now, in the merging, what problem that you will get is merging will take all the commit IDs from the source and it will put into the destination. But let's assume you are working on a test branch in your local repo and you have committed many changes and you don't want all the commit IDs to be merged, because when you want to combine the code, let's say I don't want all the previous commit IDs, but I want only one commit ID of my choice, then merge will not be useful, because merge will take all the commit IDs and it will put it to the destination. So if you want to selectively copy or combine the content of one commit ID at a time, then you should be using cherry pick. Okay, so when you say cherry pick in Git, it will allow you to take one commit ID from a source branch and it will be combining or merging it to the destination branch. Okay, so that's the difference. So you do the merge when you want to combine all the commit IDs from the source to destination. However, if you want to combine only one commit ID of your choice, then you can choose cherry pick. Okay, so let's see that how it works. Now, when you do a merge can be done from a remote repository as well as your local repository, because merge happens from one branch to another branch. So you also have branches in the remote repo and the same copy is also available on your local repo. But remember, if you do a merge in your local repository, then you need to push that changes once again to the remote. So that's where, if you are trying to do some merge in a branch which is needed by everyone, then you should always do the merge again from the remote repository. Okay, but however, let's say you are trying to merge from your test branch to main branch or release branch, then that cannot be done from remote repo, because the test branch will be available only in your local repo. So in those cases, you can use the local workspace and the Git client to do the merge. So that's where, once again, remember when to use Git client and when to use the repo. Okay, so any changes you want to do for everyone, then do it on the remote repo. And if you are trying to do something only for your purpose, then do it on your Git client in the local workspace. Okay, same way, the cherry pick is not available on your server side. Okay, so typically, now this is where for cherry pick you need to use the git client commands and merge from the source to destination. Okay, so let me show you both. Now before we do that, so let's come back here. Okay, so now what I can do is, if I want to do the merge from source to destination, now let's go to the GitLab server. Okay, so how do we do the merge? So now in the repository, if you see, there is an option called merge request. Go to merge request. Okay, let me just minimize the screen. So merge, now come down, create a new merge request, And here you can choose in this project what is your source branch. Now, for example, let's say I want to merge from release branch to main branch. So let's say my source is release branch and my destination is main branch. Okay, then let's go ahead and say merge. So you're just trying to combine. All right, so cross verify. So come down. Now, if this option is enabled, just remove this because GitLab will delete it once the merge is done by default. So you don't want this to happen. So remove this and then go ahead and say create merge request. Now, basically what happens in GitLab, you can approve whether the merge should be done or not. Okay, so that's another benefit that you will be getting if you do the merge from the server, because it doesn't mean that if someone wants to merge, you're directly allowing. So someone has to verify, and is it really necessary, and are you doing it correctly? So that way, in GitLab as a server, you can review the merge request and then you can go ahead and do the merge. So that way now, if I click on this merge, okay, so you can see it says merge has been done. So now if I go back to repository and let's say files, okay, so now you can see this is the main branch, and in the main branch, along with your main file, you also got the release file that was merged from the release branch. Now, how did you get? Because the commit IDs also got merged. So practically when you say merge, it's not the files, it's the commit IDs that gets merged from the source to destination. You can see. So this is how, when all the commit IDs from the release branch has been merged or combined to your main branch, you see both the content. Okay. So this is how you do the merge on the server. Now again, I have done this merge, but come back, and this is where if I want to pull that changes, because that merge is not still available on your local repo. So let's say git checkout master. Okay, what is it saying? I'm sorry, it's not master, it's main. Okay, so now in the main, you should still see that we are referring to the old commit ID and we don't have the latest commit ID which is created by the merge. So now if I say git pull, it should update whatever is available on the remote repo. So now you should see that release file is also being updated. So this is how whenever you want to update. So now you can see when you did a pull, it pulled from the main branch of the remote repo to the main branch of your local repository. Okay. Now, in this example, so we have the branch called test branch. And what if you want to merge the test branch to main branch? So now this merge cannot be done on the remote repo. So you have to do it on the local repository. So for that, what you can do, you can again use this command. So we can say git merge, and you have to tell what is your source branch or what is your destination branch and what is your source branch. Okay, so in our example, the source branch is test branch and the destination is main branch. Now, what you can do is you can check out to your destination branch and directly just say git merge the source branch. Now, if you do not give the destination branch, it will take your current branch as the destination. So now if I say git merge test, it will take the content of the test branch and it will merge to the main. And here it will merge all the content. Okay. Now this is where what I'll do, let me not do it directly, because let's go to test branch. Now I told you merge will take all the commit IDs, right? So let's do a couple of more commit IDs and then merge it so that you will see. So you did a commit for new file. Okay. So let's quickly add another file called new file 2. because of this, so what you should see now, in the test branch, you have two commit IDs, 841 and DAB. Okay, so let's do a merge and you should see both this commit IDs onto the main branch or your destination branch. So git checkout main branch. Okay, so see here, you don't have those two commit IDs as well as we don't have those two files. So now when I say git merge, the source branch is test and the destination is the current branch. So it's trying to merge, so it's asking for a commit message. So you can change or leave it as it is and save this file. Okay, so there's a VI editor, so I'm just saving it using :WQ. Okay, so because of this, now if you do ls, you should see both the new file and the new file too. And corresponding to that, if you look at the commit IDs, you see that both these commit IDs have been copied. So this is how, when you do merge, what merge will do, it will take all the commit IDs and it will be combining it into the destination branch. Okay. Now, however, as I said, what if you want to combine or take only one commit ID of your choice, not everything? Then you should be using the cherry pick. Okay. Now for that, what you have to do, you need to use the command called git cherry pick. And what is your commit ID from the source branch that you want to put it into the destination branch? Okay. Now let's see how this works. So once again, I'll go to the test branch. Okay. So what we will do here, we'll try to create two commits out of two files, and then we'll pick any one of them. Okay. So first for this, what I'll do, I'll create a file called as day, and I'll say git add dot and git commit. Okay, and same way I'll create another file called night, git add dot git commit. Okay, so now you should see two files called as day and night in the test branch. And not only that, okay, so we have two commit IDs. One is CE2 for the day file and 93D for the night file. Okay, so now if I do merge, it will take both of them. So instead of that, if I want to pick any one commit ID, then you should use cherry pick. So that way, let's say I want to take the night file, or I want to merge only the commit ID for this corresponding file. Then let's go to the destination branch. So let's go to main branch. Okay, and now here if I say git cherry pick, okay, and you can give the commit ID. So what will happen now, git will merge only this commit ID from the source branch, that is the test branch, to the destination. So that way, see now here it has taken only the night file. Okay, so you don't see the file called day. And not only that, you can also do a git log and check only this 93 will be taken. Corresponding to that, it has generated a new reference. Okay, so the commit IDs will not be the same, but this is exactly the reference to the commit ID called 92 or 90. Okay, so this is how merge combines all the commit ID from the source branch to destination branch. However, if you want to pick one commit ID of your choice and then merge from source to destination, then you should be using cherry pick. Okay, again, in interview or in general, if someone asks, you should know the difference. So merge takes all the commit IDs. whereas cherry pick will take one at a time. Okay. Again, just to recap. So remember, if you're merging for everyone, then do it on the remote repo. And if you are doing a merge on your local repo, then it will be available only on the local repo. So you have to do a push once again after your merge from the local. So that's where usually we don't suggest to do merge from your local repo. And if you want to do cherry pick, then it will happen only through the Git client. Okay. Okay, so pretty much now we understood what do we call it as branching and how does branching works. And once you have done with the changes, how do you combine the code from one branch to another branch using merge? Okay, now what's the next topic? So there's a topic called tags in in general in Git. Now, what is tag? So what happens? See, when you take a repo, there are many branches. Now, inside a branch, what do you have is commit IDs. Now, every commit ID is a unique 40 characters ID, right? So what happens now, at any point of time, if you want to refer to a commit ID, it will be very difficult for you to identify a commit ID because remembering 40 characters is not an easier task, right? So that's where we need an easier way to identify a commit ID so that if you want to go back for any reference and you want to have a look, you should be able to easily identify. Now, this is what we call it as benchmarking, okay, or baselining. Now, how do you quickly identify a commit ID? Now, that's where we use a concept called as tag. So basically, tag is like a name which you can associate to a commit ID. Okay, so for every commit ID, you can create a tag which is nothing but a name. Okay, so the name what you give will be unique. For example, if you let's say go to a shop and you're trying to buy something, so every material has its own price tag using which you can uniquely identify, right? The same way in Git, for every commit ID that you need, you can create a reference name and you can associate it to the particular commit ID. So this way, let's say a tag can be used to identify when a release happened. So for every release, you can create a tag name and attach it to a particular commit ID so that instead of remembering the commit ID, if you refer to the particular tag name, you will be redirected to the same commit ID. Okay, and not just that, you can also use tag to mark your day-to-day activities like testing. So let's say developers commit code and after that you do some testing like functional testing. Now at some point of time, if I want to know what is the last commit ID in which the functional testing has been completed. So in that way, you can apply a tag called as functional testing and keep moving this from one commit ID to another commit ID. So that way, tags are nothing but name which can be associated to a commit ID for quick reference. And remember, one commit ID can have multiple tags associated. However, one tag cannot be applied to two commit IDs at the same time. So as you can see the diagram, each commit ID has its own tag. However, one tag cannot be applied to two commit IDs at the same time. For example, like if I say release 2, you need to mark it on a particular commit ID in which release has been done. Suppose if I say functional testing, that is the FT that I have referred. Now I can apply to one commit ID now. Later, tomorrow, let's say there is another commit ID on which I have completed my functional testing. Then I will remove the tag from this and you will be applying it on another commit ID. So that means tag will be associated to only one commit at a time. However, one commit ID can have multiple tags. Okay, so let's see how we create tag and how do we use tag. Okay, so once again, when you say tag, you can create a tag on the remote repository or on your local repository. Okay, so if you create a tag on the remote repository, then it will be available for everyone who does the clone. But if you create a tag locally on your workspace, then it will be only visible to you in your local workspace. And then if you want to share it with everyone, then you have to push the tag from the local repo to remote repo. Now that's where, again, it's not encouraged. So anything that is needed by everyone, you should do it only through your remote repository, that is using tools like GitLab. Okay, so now let me create a tag here. Okay, so here it's asking you what is the name you want to create. So I'll just say test tag. Okay, and on which branch that you want to have, you can typically give a name, and I can just say dummy tag. Okay, so what's happening now, you created the tag and it is directly applied, okay, to a latest commit ID that you have. Now this is where, instead of doing it, if you are trying to apply it to a particular commit ID, then you should be using your client command. Okay, so if I say git tag, okay, so you can say -a and you give what is the name, or technically we call it as the pattern or the string, followed by a message what you need. Okay, so now let me show you here on the client. Now let's say git log, and we have this commit ID. So what we will do, I'll say git tag -a and we'll name it as dummy tag. Okay, and -m, and we'll just say a message, and then followed by which is the commit ID on which you want to apply. So this is the commit ID. So if you now do a git log, you should be seeing on this particular commit ID, you also have a tag called dummy tag. And to see all the tags in your repo, you can just say git tag. Okay, so git tag will show you all the tags available on your repo. Now what's the benefit? Now this is where, now let's say I want you to go back to a old commit ID. So that is the commit ID that we have used for the dummy tag. Now without the tag, remembering the ID will be difficult. So that's where, now if I want to switch from one commit ID to another commit ID, I can always refer that tag. So simply if I say git checkout and the tag name, okay, so instead of remembering the commit ID, if I now say this, see what will happen. It will exactly switch from your current head reference, and it is exactly going to this particular commit ID, because this is the commit ID which we applied the tag. So that's how tag will be very useful for us to identify or act as a quick reference for our commit IDs. Okay, and if you want to see the tag details, what you can next do, okay, it just got hung. You can say git show and you can refer to the tag name. So what will git show do is give the complete details. So you can see this tag called dummy tag is associated to the particular commit ID called 39FB. So at any time, if you refer to the dummy tag, it will be redirecting you to the particular commit ID. Okay, so that's how tagging will be very useful, especially when the development process is happening or the sprint is happening, after they complete each of the testing like functional testing or integration testing or regression testing, they can benchmark the commit ID by applying a tag. Same way, whenever you do a release, you can also benchmark the commit ID by applying a new tag or a release tag on top of it. Okay, so that way you can use tags to quickly identify or act as a reference name for your commit ID. And once again, here to just see, you can use git tag and it will show you. And if you want to see the details, you can just give the tag name and it will show you what is the reference. Okay. All right. Now, pretty much we have seen what is branch, and we have also seen what is merge and what is cherry pick, and typically we just now saw what is tag. So the other concept that we also have in Git is, I told you in the beginning, Git is a distributed version controlling system. So what is the meaning of distributed version controlling system? So it is not mandatory for a user to do a push or a pull only to the origin or only to a particular remote repo. So the user has the flexibility to push or pull between many other repositories locally or remote. Now that is where, how does it work? We need to understand. Okay. So for this, now what happens by default so far? There was a remote repository, so which is what we call it as the origin remote repo. So you do the clone, and once you do the clone, you will be getting everything here. Now in this, we were trying to do the push or pull from the branches of your local workspace to the remote repository of the origin. So that is how it was working. But in Git, what you can actually do is you can choose to push or pull to other repositories also. Now, just for understanding, I have put here that you have another new remote repository as well as you also have another local repository created. But what happens in Git if you are trying to push or pull to another remote repository? It is possible. Okay. However, if you want to share the content from your local repository to another local repository, then only pull is allowed. Push is not allowed. So what do you mean by that is, if I want to pull changes, now you can see I can pull from the origin, or I can pull from another remote repository, or I can pull from another local repository. It is possible. But if I want to push some changes, then I can push only from my local repository to only a remote repository. So that remote repo can be your origin or it can be another new remote repo. But remember, by default, you cannot push from one local repo to another local repo. But you can pull from one local repo to another local repo. Okay. So in general, the repository available in the remote repository, right, is called as bare type of repository. The repository that you have locally inside your workspace is called as non-bare repository. So this is where push can happen between a non-bare repository to a bare repository. So it cannot happen between two non-bare repositories. If it's confusing, just remember this much. A push can be done only from a local repo to a remote repo. Push cannot be done from one local repo to another local repo. However, pull can be done between a local repo and a remote repo, or a local repo and another local repo. Okay, so this is why Git is called as distributed version controlling system. Now, in this, so far we were only doing a push or pull from your local to the origin remote repo. And for that, we use this option called push.default was simple. But how do I now push or pull to another repository, which is not your origin or which is not your original remote repository? Now, this is where we need to use some settings. Okay, so pay attention what we are going to do. Okay, now inside your local workspace, if you just say git remote -v, so this will exactly tell you what is your origin from which so far the push and pull was happening. Okay, now for that, now let's say for example, now let me just go here. So in this repo, if I just say git remote -v, so you can see it says origin, and this is the location. So this is where the push and pull so far was happening. Not only on this, you can go to any other workspace, let's say workspace 2. Even here, by default, you can see the push and pull was happening between the local repo and to this remote repo. Now this is where, how do you set a different repo to which you want to work? Okay, now for this, first what we will do, I'll create two new local workspaces. Okay, so quickly what I'll do a clone. Okay, so first I will do a git clone and I will call it as okay, so we'll call it as W4. Huh, okay, let's not, it's not doing it properly. Okay, so let's say I'll create a clone called W4 and we'll clone another one called W5. Okay, so we have two new repo created, W4 and W5. All right, so let's use that. So what I'll do, I'll go to W4 first. Okay, and here, now let's take any branch. It doesn't matter what branch you are taking. So let's say main branch. Now in this main branch, right now you can see these are the files available. And what is the commit ID that you have? So the latest commit ID what we have is AABD. Okay, so at this place, let me create a new file called W4 file. Okay, so that it's easy for us to know. So this is a file that I'm creating from the workspace called W4 on the main branch. So let's go ahead and add git commit. Okay, now because of this, so you have this file as well as you have the commit ID, which is called as 660E. Okay, so now, as I said, we can push this to another remote repo, but I cannot push this to another local repo. But from another local repo, I can pull from this. So that's where, now let me go to this workspace called as W5. So in the W5, you see nothing is there. That means this W4 file is not there. And here, what is the default remote repo? These two. So now, if I want to pull from W4 to W5, because by default, if I say git pull on the W5, from where it will take, it will go to the remote repo that is the origin, and it will try to pull. So instead of that, if I want to change, then this is where what you have to do. You need to use the git remote and add a new reference. So you should say git remote, okay, add, and give a reference name followed by what is the path for your new repo to which you want to push or pull. Okay, so in this example, watch what we will do. So right now, both my repos are locally. So this is where what I'll do. I will say git remote add, and I'll give a name called as demo. This is my reference name. And what is the repo? This is the repo. Okay, so see what happens now. As soon as I added this, so it clearly says now your origin points to this remote repo. However, if I refer to this demo as a project, it points to this W4 workspace or W4 local repository. Now this is where what you can do. If you want to pull, if you just say git pull, by default it will take it from the remote repo. But instead of that, if you say git pull, and you have to give the reference name. So this is when, if you actually go back, okay, so when you do a git pull, you need to basically tell what is the reference name in which your repository is available, and what is the branch in which you need to push or pull. The same thing happens here also. I'm sorry for that. Okay, okay, so far when we used the git pull or push yesterday, we never used this option because we had set the push dot default as simple, so it was always going to the origin and it was always going to the same branch. But now using the pull and push, you can also refer to another repo using this reference name, and that's where here, if you come back, so now instead of the origin, I can say demo, and in that, from which branch you want, from the main branch. So what it will do now, instead of going to the remote repo main branch, it will go to this local repo and it will try to pull from the main branch of this. So watch what happens now. So you can see now the file that we had called as W4 file was not in the remote repo, but it was on the local repo. So this is how, what you can actually do is you can set the remote repository location by adding a new reference, and the pull or push that you want to do, you can do it accordingly. So all you have to do is refer, when you're doing a push or pull, the name of the remote repo that you have created as a reference name, and in that which branch that you want. However, as I told you, I cannot push from one local repo to another local repo. Okay, so this is how you can share changes, not just with the origin remote repo, but you can also share changes between two local repo. But the only thing you have to understand, push cannot happen from local repo to local repo. Push will always happen from local repo to remote repo. However, a pull can happen between two local repos also. Okay, so that's what we have seen. All right. Again, this might not be your day-to-day use case, but generally something like an interview, if a question comes up, you should be aware of it. Okay. And finally, there's one more topic. Most of the time, again, it's just from an interview perspective. So there's a concept called as fetch. Okay. Now, this is again a popular question that people would ask. What's the difference between a fetch and a pull? Okay. So far we understood pull. But what is fetch? Now that's where let's understand a little deeper into what is pull or what is fetch. Okay. So now when you actually execute a command called git pull, what happens is there are two steps which pull does. Pull will take all the references or the commit ID information, or in general the metadata from the remote repository, and it downloads into the local repository from where you're executing the git pull command. Okay, so that's the first step. So git pull will download all the metadata and the references from the remote repository to your local repository. And after that, it will be updating the references or the metadata into the branch. So that is how you will be able to see the files. So as soon as you do the pull, first it downloads and then it merges the content into the respective branch. So that is where when you go to the working directory, immediately you are seeing the file. Okay, just like in the previous example we saw, right? When I did a pull, what happened? I was able to see the files and I was able to see the commit ID. That is because pull does two things. It downloads all the reference and metadata, and it integrates them with the respective branch. So that is how you will be able to see the files in your working directory or the local repo. But for some scenarios, you will not be interested to actually see the file. If you are interested only to update the repository references by only downloading it, then you can use fetch. So what does fetch do? It doesn't do the second step. It does only the first step. That is, when you do fetch, it only downloads the metadata and the references from the remote repo to your local repo. However, it will not be integrating it into the branches. So that means you will not be able to see the files. Now this way, it is going to be a little effective where you are not interested to see the files, but just you want to keep your workspace up to date only from the references. But whenever you want, then you can exactly check out or switch to that particular content. At that point of time, git will try to integrate the changes. Okay, so if not, the very simple difference, git pull will download and it will merge or it will integrate the content into the branches in the repo. Whereas when you say git fetch will only download and you will not be able to see them unless and until you explicitly check out and go to that particular content. Okay, so that way fetch only downloads. Okay, now how does it work? Let's see that quickly. Now, once again, for this, what we will do, we'll again create two new workspace. Okay, so that I'll show the same difference. Or let's not go and create new workspace. Let's use the same W4 and W5. Now let's go to W4. Okay, so here we already created one file called W4 file, right? So I'll create another file now here. Okay, now we'll call this as fetch me. Okay, now because of that, we have a new file called as fetch me on the main branch. Okay, now watch this. So this is available only on this repo called as W4, which is a local. So now corresponding to this, if I say git log, there is one new commit ID called CE4. So now if I go back to this repo, okay, now here we don't have that file, as well as we don't have this commit ID also. Okay, this commit ID is not there. So watch what happens. If I do a pull, we know that it will update everything, right? And you will see the commit ID, and you will also see the fetch me file here. But now if I just say git fetch, okay, and this is where you have to tell your reference, but where are we fetching? So unlike you are not fetching from your remote repo, so we are fetching from our demo, and the branch is main branch. Okay, so if you run this, just like the pull command, fetch command will work, but it will only download. So that's where what it has done, you can clearly see it is downloading this metadata or the references into your local repo, but it would have not integrated in your workspace. So you can see you still don't see that file called fetch me file. So where is this content available? All it has done is it has downloaded, so that if any future references you want, you can refer. So that's where pull will download and it will show the file, whereas fetch will only update the metadata, that is the references. It will not be showing the file. So the same command, see, if I now say pull, along with downloading the content, it will also show you. So this is also downloading, but along with downloading, now you see the file is also available, whereas fetch only downloads the metadata. Okay, now if this is confusing, let me do it again. This time we will create it with the new branch. Okay, so watch what I'm doing. So I'm going to the W4 workspace. Okay, so here let's create a new branch, okay, called as test fetch. Okay, and let's check out this branch called test fetch. Okay, and here we will create a new file. So I'll call it as you can see me. Okay, so I've created a new branch called test fetch in this W4 workspace. So what we will do now, let's go to W5. Okay, and see here, if I do a git pull of the test fetch branch, you will get everything. But if I say fetch instead of pull command, it will only download the references but not everything. So this is where if I say git fetch, my reference is demo, which is nothing but the W4 folder, and here we will give the branch called test fetch. Now this is where what it has done, it has downloaded the details. You can see, so it has just downloaded. So fetch is useful where you don't want to see everything, because if I had done git pull, it would have created the branch as well as all the files will be also available. But instead of that, if you want to only download the references, you can use git fetch. At this point of time, if I want to see the content, then as usual, if you say git checkout and test fetch, only then the files will be actually integrated in your repo. Okay, so in short, fetch will only download the references to your workspace, whereas pull will download the references as well as it will integrate all the changes in your local repository. Okay, so that's the main difference that you're going to have. Okay, so pretty much that's what we have. So now if you go back in git, so all the concepts, what's more important, right? So it's branching, and we also saw how do we integrate or merge between two branches, and what's tag, and how do you push or pull between two repositories, for which you need to add a new reference called as remote reference. And then when we are doing a pull and push, you need to explicitly tell what is the reference name in which your remote repository is pointing to, and as well as what's the difference between fetch and pull. Okay, so that's what we have.